This is a replication of Howard Johnson's 1979 linear motor patent. It has a few modifications, updated modifications, and those I'll explain. In Howard's patent, he's got 6 magnets consecutively running at closer and closer proximities to each other. This space is the widest here, then it gets a little bit more narrow, more, and there's your 6. Then there's another 6 here, and another 6 here that do the same thing. This particular piece here is, let me zoom in on that a little bit, is your key to the entire operation. It's an arched magnet. This is made of N52s. I'm going to show you how to make it. And what we have in here is just about 2 or 3 pennies that are wrapped in some masking tape and stuck down to this little cart for ballast. And up here we've got about 8 or 10 here and about 8 or 10 here that are wrapped up again for ballast. Because what this is, this first area right in here is kind of a medium flux density and helps give this a little forward motion. And then this is a pulse gate here, and as it comes close to the gate pulls it in, sucks it right in, and then shoots it out like a slingshot. Then it goes through this next section of 6 here, which even though it looks like it has quite a few magnets, they're just cheap ceramic magnets, maybe N8s or something like that, just very, very weak, and they're old. This was one of the first things that we built years and years ago as a demonstrator to prove the theory. And anyway, this is a weaker field here, and so as it slingshots out of the gate, it glides through this weak field until it hits this final 6. And because of the alignment and proximity of these magnets the way they are, you can see that this was just a cheap little hack job of putting it together. Anybody can do this. I want you to do it. If you do this, you'll just be absolutely, totally amazed. It's so unlike a V-gate, and I'll explain that in just a second. But these magnets here, they're just this size here, and I just broke them in half so many years ago. I just scored them and snapped them in half just to modify these fields. But this final field here is pretty strong, and so it pops it out. But it starts at about this point, at the beginning of the 6, and then it just sort of gradually builds up and then pushes it out at the end. Whereas the gate here, the pulse gate, is more of, it seems to work on a subatomic particle level, because it just, as it pulls it in and then slingshots it out, it's just absolutely fascinating. But I think the major difference between this and what Howard did in 1979, well, actually he did it a lot many years before 1979. It just took him that long, up till 1979, to get that patent, because the patent office just would not admit to the fact that he could move a mass from point A to point B without some other form of energy like batteries or something to power the device, because this is working totally on magnetic lines of flux, and so I'll show you. But the key here really is the asymmetry between the magnetic flux strength of these weak ceramic magnets as opposed to these N52 neos that make up this arch. You have a north pole here, you have a south pole here. All this is here is just a release. When I press this down, it fires. Boom. Boom. So it goes fast. Unlike a V-gate type operation, when it reaches the end, on a V-gate, you have some sort of magnetic structure coming, and then it just stops, right at the very end. This thing blows it out the end. In fact, if I had more track, it would go quite a ways different. So it's enough to bring it back around to the front, if this is in a circular or some type of a pattern that will return it, and pull it back in through this very weak little field here until it gets up to here, and the gate sucks it back in and blows it back out a second time around. That's what should be explored even more than what we've done here. We've beefed up this gate, and we added double arches to the rotor, the little rotor car, I don't know, whatever you want to call it, cheap piece of junk here, but it works. It works very, very good, and it proves that Howard was right, and this is really amazing. You can actually get something that you just never thought was possible. Now let me set this back up again. This latch here just simply holds right here, and all it does is just hold the car, because the car wants to go forward and then get sucked through the gate and blown out through the other end. Now let me just explain momentarily here that what we've got is well, Newton's law states that F equals ma. In other words, that force is equal to mass multiplied by acceleration. Energy in physics is the ability or capacity to do work or to produce a change. And that's what this device does. And grab my pointer here, my chopstick pointer. So energy exists in various forms. It can be converted from one form to another. In this case, it's magnetic force fields to accelerated motion. So as I was stating before, the asymmetry between the flux density of these cheap little ceramic magnets versus these N52s, and then going through a gate where the actual arch goes through the center area of the gate, is what makes this possible. And because of the varying field, that custom modified field, which gives you this curve, you can see the distance between these magnets on the stator and this rotor, so to speak. This is called a linear motor, even though it looks like a car on a track. That's what it is. But work is the exertion of force over a given distance. And in order for work to be accomplished, there must be a displacement in space. That means that something has to be moved from point A to point B, or wherever you want to put point B. So it takes energy to do that. Well, in the Howard-Johnson linear magnetic motor, the energy required for such exertion of force is obtained from the force fields of these properly aligned permanent magnets, and thus moving the accelerated mass over a distance from point A to point B in time. That's exactly what this does. So the conclusion of that is that permanent magnets can provide a form of energy, so long disputed by physicists. And you can so easily see it done. Watch, I'll just barely touch the release lever here, just pushing it down just slightly, just to release the car, and boom, it just shoots out very, very fast and would keep on going with enough acceleration and enough mass of weight to enter back into the beginning and pull it right back through the gate again. I'd like to make one more point perfectly clear here. I've got a scale. Let me just turn this on, let it calibrate itself. Okay, we'll take the little rotor car, set it on there. 3.7 ounces. 3.7 ounces. That's the mass that we're talking about. Remember, to move mass from point A to point B requires energy. And force, it takes an exertion of force, so it takes the work to make it do it, but the energy provides that work. And the energy in this case is in the form of magnetic flux.